Welcome everybody to the second day of hash table week. And what we're going to go over today is not how to make your own hash table, but how to use the hash table in the standard library. Okay. And so, ordered map. So we're going to be doing Shimapu. So let's say that we have a class for a person, and maybe later on we'll make it proper class designing. For now, I'm just going to kind of demonstrate this to you. So we can have a string for the name, and a for the social security number, and a string for the address, and for the income, something like that. Okay. And we want to be able to quickly, in order one time, see if a person is in our database, and if they are, pull the record, right? Pull the data we want for them out. So of these four things here, which one of them is most likely to be unique? What should we use for the key? So the key is the thing that you use to insert and search and delete the record. Yeah, social security, exactly. Social securities are used for this purpose because they are unique. You could have two people with the same name. So what we're going to do is we're going to make an unordered map, mapu between a integer and a person. And we're going to call this database. And the social will be used to, that's what we're going to store the person's record under. And when we look for them by their social. If we wanted to look for them on any other field, we would have to just kind of go through the entire database to find it. So if we want to add somebody to the database, there's kind of two different ways of accessing a hash map in C++. And I'm going to go over both of them. There's what you might call the proper way, but the proper way ends up having the syntax that looks really ugly. And so the dangerous and sharp-edged way is oftentimes what I write, just because I know how to sort of avoid the sharp edges involved. So let me show you guys the proper way first, then I'll show you the way that I actually write it. Option 1, proper way. And so we've got the safe way. Yeah, the safe way is better. Okay. The safe way, like a grocery store. Okay. And so we want to do insert, we want to do search, and we want to do delete. Although for this assignment, maybe you don't do delete. I don't know. Okay. We'll just do insert and search for now. So we want to, we can just make a person. Who wants to be a person? Who wants to be in the code for today? Pool. All right. So person pool is equal to Corbin pool with a social of 2323, an address of 111 Main Street. Sorry that I'm doxing you like this, Corbin. And, or sorry, not Corbin. Pool, what's your first name? And then an income, Chris. Sorry about that. Yeah. It's Corbin Beatty. All right. Sorry. Chris Pool. And then a income of $423,000 per year. I'm using braced initialization syntax to do a constructor here. Again, for your homework assignment, you're going to want to use proper class design. I'm just doing this to demonstrate. So we got Chris Pool here. Okay. And then we want Rohan Atal. Okay, so Atal. And that's your brother, right? What's yeah, Rohan. Okay. So there. And your social is going to be this. That's too many digits on it. And then your address is 9113 Park Place. And your income is this per year. All right. You can add some decimals in there so you guys can count the income digits. All right, Ella Hansen. Your social is that. Too many digits again. And you live at Park Place Boardwalk, of course, 411 Boardwalk Way, and your income is $763,000. Congratulations. And this is going to be Hanson. And then Hanson, sorry. Hanson, oh my gosh. There's 3 Hansons in this class. Yeah, sorry. Okay. All right. And then BD. All right. So BT, and this is the Corbin I was thinking of. Corbin with a E, not a Y. BD with a social of that, and an address of Baltic Avenue with an income of, I already got an income of 150,000. Income of 222, no. 222. There you go. Congratulations. Now we're going to add these people to the database. All right. So the proper way of adding it is using database.insert. And what we're going to insert is the key. Whenever we work with these things, they take key value pairs. Okay, so it takes 2 things. It takes the key, which is what we're going to use to insert, search, and delete. Like, that's what we use to pull the record. And then the value is actually all of the data with your income, your address, and all that kind of stuff. So we're going to insert the, we're using social as the key, right? So this is the, call it primary key. And so we're going to use pools social, pool.ssn, and we're going to insert pool, like that. And we're going to pass this in using braced initialization syntax. And there we go. So it takes in, inside of curly boys like that, you're going to pass in a key and a value. The key is the social in this case, pool.ssn. So we are passing in Chris's social security number, and that's what it's going to use to store his full record in. And then later on, when we look it up, we're going to use the social also to pull the record. So we're going to do this for all 4 people. And so 4S Otal dot 4S Hanson with an O dot and 4S BD and a dot there as well. Okay. So now we've got all of the people in our database set up. If you want to print everybody in it, we can do a range-based for loop. Now, the range-based for loop is going to return you a set of key value pairs. Every time you do anything with a hash map, you get a key and a value, and they kind of come together. They come with each other. So we're going to say for, and now we could say auto, and in practice, I would use auto because I don't want to type all this, but I'm going to show you kind of what's happening here. It's going to return a pair. It's going to return a pair of, and we're going to make this a const pair, and int and person by reference p in database. So we are doing a range-based for loop here. We're going to print everyone in the database. And this is going to return for each person in the database. It's going to give us their key, which is going to be the social security number, and it's going to give us the value, which is the full record of the person, which includes the social security number. So in this case, it's redundant. Now, technically, you don't have to have the social like in the record itself, but whatever. RAM's cheap. So we are going to see out p dot. So a pair is a very simple structure that has 2 member variables. It's got dot first and it's got dot second. Dot first is the key. Dot second is the value. So if I were to print out p dot first, this would print out the social for every person in the database. Warning loop variable binds to temporary. That is fine. Use non-reference type or use const pair constant. Okay, fine. Okay. And so here we are getting the socials of every person in the database. And if you look at it, the numbers are not coming out in any particular order. The first number we put in was the first number we printed was 4389, and that was the last one that we did. Let me fix BD's name there. Okay, so this is the key. Hey, no, key. And then the value is going to be the record of the person. So key dot second. What's a pair? A pair is this is literally what the pair is. It's template, type name key, type name u, struct pair t first, u second. There you go. I just re-implemented the standard library, basically. So this is the pair class, except it's lowercase in the standard library. So it is a templated struct where it can have two different types for the first parameter and the second parameter. And so the dot first is the key, and the dot second is the person, the record. Does that make sense, Sarah? This is what's getting returned by unordered maps here. And we cannot print a person because why do we not have the ability to print a person yet? What am I missing? What operator do I have to have in order to see out a person? Why are you guys all pointing to the person to your left? Friend ostream reference, operator double left arrow, ostream reference outs, const person by reference p, return outs double left arrow, p dot name, print out the name, print out the social, print out the address, and we'll print out the income. And SSN is capitalized. And there we go. So now we can see out all of the people in our database, and there we go. So now we're getting the full shebang, right? So we're getting this is the key, and then the value is the full record. Do you guys understand what's happening here? We're like building a database of people, and we're going to be looking for them using their social. Okay, the key is the social in each case. Okay. So we have now built the database. We can print the database. Now we are going to search the database. What's value? The value is this. It is the like imagine you go into HR, Sarah, and you're like, hey, I would like to get a raise or something, and they're like, okay, what's your name or what's your employee ID? And if you give them your employee ID, and that's what they use to find, they go through they pull out the physical paper drawers and things like that, and they flip through it. Whatever it is they're flipping through on is the key. It's like if they're searching you by name, your name is the key. And when they pull that manila folder out that contains all of your life information in it, that's the value. The value is your dossier. It's got your name in it, your employment history, your, I don't know, traffic tickets. I don't know what's in it. In this case, the value is name, social, address, and income. Yeah, we're basically putting records into a database, and then here we are printing everything out. So the value is the entire record of the person. But the terminology in computer science is a key value pair. And so that's some terminology that just everybody uses. Okay, so if we want to search for people, search for people using find. Do we write the value or does the computer do it for us? This is the value right here. So when I inserted it into the database, the key for pool is pool.ssn, and the value is the entire record for pool. And so do we write the value or does the computer do it for us? We pass the value to be stored, And then here, where we're getting all the information out of the database, it's pulling the data for us. And .second is the value. Okay, so searching for people using .find. So string s equals, no, the keys are socials, so we're going to use integers. Integer sn equals read. Type in the SSN of a person we want to look up. So we're now, in the HR office, and somebody comes in, and they're like, "Hey, I want you to pull up my employment history." You're like, "Okay, what's your employment ID? Or what's your social, or whatever?" And they give it to you, and we're going to type it in right here. Okay. So what we're going to do is we're going to say database.find, and we're going to pass in the SSN. So we pass in the SSN, the student ID, the employee ID, whatever. We pass it into find, and then find returns an iterator. And if you remember, iterators are like pointers. And so if Corbin is in the system, if we type in 4389, if Corbin is still in the system, then this is going to return a pointer essentially to that record of Corbin in the database, and then we can pull his data out of it. If it's not found, it returns a special sentinel value, and you can check for it not being found like this. So if the iterator equals database.end, not found. Okay. So it returns a pointer to one past the end of the hash table. And this is true for like most of the standard library stuff. If you ask it for a pointer to something in the database and it's not in there, it returns a pointer to one past the end, which is the .end iterator. And so if it's not found, we just print out not found. Otherwise, we will see out star iterator. Sorry, that doesn't work. Star iterator is it's a pointer to a pair, so iterator points to second. Sorry. So remember, everything that you get from a hash map is a key and a value both. So it returns an iterator pointing at both the key and the value. So if you want to get the value, you use that. And so this is a person. And there we go. And so if you wanted just the name, see out the name person you look up. Iterator points to second dot name. And so it looks a little bit wonky. He's got a point, you got an arrow operator, you got a dot operator, Such is life. This is why this is the version I don't exactly use very often. Okay, so type in the social of the person we want to look up. Let's look up 11111, not found. Let's look up Corbin. Corbin's social is 4389. Name of the person you looked up is Corbin Beatty. Name Corbin Beatty, social 4389, address 2332 Baltic Avenue, income 222222. And it could look that up in order one time. Okay? So it was able to find, we could have billions of people in this hash table. As long as we have the RAM to throw out the problem, we can find any person in this database by their key, by the social security number in one operation, which is good. It is very, very good. It is very, very fast. If we search for an entry that doesn't exist, wouldn't that add it to the database? You are anticipating part 2 of this lecture. I'm going to show you the Sharp Edge version that will do that. Okay? So this version is the safe way. Remember, it's like the grocery store. It's the safe way. Right? This version will not accidentally add things to the database like the square bracket way that I'm about to show you will do. Okay? Pick and save. Family dollar. With SQL unordered map, how often are collisions? Up to 90% of the time. Up to 90% of the time. The standard library implementation of a hash table is not great. Let's put it that way. There are much, much faster implementations of doing a hash map. than the way that we're kind of stuck with in the standard library. But you know what's nice about it? You don't have to write it yourself. I mean, you can write one. Like I wrote a hash table last class in a couple minutes, but it's nice. It gives you all this kind of stuff and inserts and searches. It's all done for you. You don't have to handle it. It's not great performance. Like quite legitimately, it is well known that the standard library hash table implementation is garbage. Like, just not, like, in terms of speed, it is just not good. It is not a good implementation. There are much faster implementations you can find on GitHub that are like 10 times faster. And what's funny is that like a hash table is already like the fastest data structure, right? And so we use hash tables for speed. And the fact that it's not as fast as it could be is kind of like, it's unfortunate. It's easy. Yeah. Okay. Is that something they can ever change? That is a politically loaded question, Corbin, because the answer is yeah, they could fix it. They could. But it would break existing code that used the unordered map. And so you would have to do a full recompile. If you had compiled .o files that use the old version of unordered map, and you compiled it against a new unordered map, those things are not going to link against each other. Or even worse, it does link, and then you get weird undefined behavior. And so this is the single biggest issue in C++ right now, which is whether or not to break backwards compatibility. Because up until now, every time we have updated the C++ language, we've actually been able to preserve compatibility with compiled .o files from previous versions. We have not broken what's called the ABI. And there's no guarantee of that. The Standards Committee has never promised to never break backwards compatibility, but they've avoided breaking backwards compatibility. And so it's like, is this the rule? And people are like, no, we just haven't done it yet. But we might, but it's a tough question. So there's a lot of proposed solutions for it. Like one, the simplest solution would be to do this, right? Just have a new one, right? Unordered map 2, here we go. Yeah, let's do this. Just have, and they've done this for like smart pointers, right? The original smart pointer was called like an auto pointer, something like that, but we don't use it anymore. We use auto pointer 2.0, also known as shared pointer. So, unordered map 2 electric boogaloo. Yeah, it is a contentious issue. I think they actually just took a vote on it like a couple weeks ago, and there's no consensus on it. So it's been a big issue for a long time now, and yeah, we'll see what happens. I don't know. All right, so this, any questions about this code? So we have the ability to insert into it. We have the ability to print the whole thing. We have the ability to search it. Order one time for everything, which is really fast. When older programs use the older, but the problem is mixed programs, right? So you've got a library that exists, and you change your code. Your code is going to be using the new unordered map. The library is going to be taking the old unordered map. If you pass one of the new unordered maps to the thing that's the old unordered map, ain't nothing going to work, maybe. So, so the simplest thing, like I said, is just doing unordered map 2. And then it just won't compile and everything's fine. It points to second dot name right here. Okay. So when we call find, it returns a pointer to Corbin's record, or whoever it is, whoever's social we typed in. So it returns a pointer to it. But remember, with a hash map, everything is a key value pair. So what we're getting a pointer to is actually the key in .first and the value in .second. And the .value is the actual manila envelope containing all of Corbin BD's data. Remember, every time you do anything with a hash map, it gives you a pair. And so .first is the key, and .second is the value, the record. all the person's data in it. Okay. So it returns a pointer to a pair. And so you say P, the pointer points to second, that gives you the record, and then .name gives you the name of the person in the record. Or you can just print the whole thing out directly like this. It points to second is a person. So, all right, so now we're going to do option number 2, the dangerous way. But maybe easier to read way. Using square brackets. Okay. So, let's do the same thing. This time, we got database here. And I'm going to add an entry for the person with a social of 420. And I'm going to say the person's name is Cheech Martin. Social is 420. The address is 420 Highway. I'm sorry, I crack myself up sometimes. And Cheech Martin, of course, makes lots of money like that. Okay. So, do you guys see the difference in syntax here? I'll copy one of these down here. Oops, did I undo that? And instead of doing this, I could have done it all on one line. There we go. So these two lines of code are kind of doing the same thing. This is, I mean, they're different records, but they're basically both doing an insert. So this is going to insert into the slot 420 because we're using integers as the key value, and so this is going to write into array index 420. Now note that when you do an associative array, when you do an unordered map, they do not need to be integers. You could actually, like if you had a database that was like this, then you could say calendar square bracket January 31. Right? And so on and so forth. So in this case, it's mapping between a string and an integer. With our people up top, it maps between an integer and a person record. So whatever you put inside of the square brackets here, you can think of it as like an array access. We're going to the array entry for January, and inside of the slot for January, we find the value of 31. There are 31 days in January. When we go to array element February, and in that spot in the array, we find 28. So hash maps are sometimes called associative arrays for this reason. And this is like your basic array type in a lot of languages like Lua, which is kind of a weird combination of like regular arrays and associative arrays. I think JavaScript uses associative arrays too, like this. A dictionary is another name for it, yeah. Python. So why is this the dangerous way? It's less typing. Like, look, it's like substantially shorter to type it this way. And there's less like levels of indirection in it as well. This one has the parentheses, an open curly brace, and an open curly brace, close curly brace, close curly brace, close smooth parentheses. This one only has one. What makes it dangerous is this. So if I see out database square bracket 420, then it is going to print out Cheech Martin right here. Everything works fine. Cool. Neat. What happens if I try printing out database 4200? There is no person with... Okay, I think there's no person. Yeah. There is no person with a social of 4200. What it's going to do is, as Corbin said, it is going to make a record. It is going to insert into the database at slot 4200 and put a blank record there. In Python, it'll error. It should error in C++. It should throw if you do that, but it doesn't. It does something incredibly counterintuitive. This is why it's called the sharp edge of hash maps here. Is it will add a record for a blank person and then print it out. So you see this? It is just inserted into slot 420. Now 4200. And now note that the social here doesn't even match, right? It doesn't even match the key used because it's just creating a blank person, and the blank person's constructor creates a social of 0. And so a lot of people, to stop this, they'll actually delete the default constructor. Like they'll actually go like person equals delete. No square bracket operator for you, Dr. Jones. If you do this, if you delete the default constructor, then this code down here will not work. This won't compile. So if you want to be safe, delete the default constructor. I'll leave that here. Or what you do, what I do, because I actually use the dangerous way. This will insert a blank record for SSN 4200. It's very dangerous. You get nothing. You lose, sir. Good day. Shapahashu. Why does it do this? Because it has to return something to print. And if you're asking, like, essentially it's a mistake. How about we put it that way? It's widely regarded to be a bad design decision. But at this point, we don't have a unordered map 2, so there you go. It needs to return something, and so it creates a blank entry so it can return it. Is the answer, but it should have thrown instead, in my opinion. Okay. So what we do instead? Of this is so to use square brackets properly, we use dot contains. Make sure it exists first. So you can say if database dot contains 4300, cout database square bracket 4300, else cout record 4300 does not exist. This is the correct way of doing it. So every time you use square bracket to read from the database, you first check to see if it exists using dot contains. Dot contains is C++20 only. Prior to dot contains, you would use find like this and check to see if the pointer you got out of it met. It's kind of ugly. That's why dot contains is so nice. Can't believe it took them till the last version of C++ to do it, but here we are. This is the correct way of doing it. So you check to see if the record exists. If it exists, you print it. If not, you just print out it doesn't exist. And this is a perfectly safe implementation using square brackets. And you can see this actually looks a lot nicer, right? Cout database record entry with social 4300 versus, using these pointers and things like that. So, because everybody always forgets about the dot second and the dot first kind of thing. It's actually just much cleaner to read that way. This part here is the key, and the value returned by the square bracket operator is the value. It's all good. It's all nice. And That's about it. That's about all you guys need to know for the upcoming homework assignment, which I will now talk about. So your new homework assignment is called the Gilded Rose. This is a famous code kata that you can find on GitHub somewhere. And we're actually not doing the one that's on GitHub. The reason for that is because I don't want you having the answer available. Also, it's inspired by it. Let's put it that way. It's inspired by it. So what you're going to do is you are going to make a magic item shop for World of Warcraft, let's say. So the Gilded Rose is a place near the auction house in Stormwind. Don't ask me where it is. I have never played Alliance, I think. I don't recall ever playing Alliance. Pretty much only played Horde. So, yeah. Don't ask me, dude. I do not know where anything is in Stormwind. I can tell you all about Orgrimmar. Stormwind. Yeah, I have no idea. Sorry. Yeah, for the Horde, exactly. Anyway, so that is where the name of the assignment comes from. So what we're going to do is we're going to have items for sale at our magic item shop here, and the items for sale include things like Sulfurous, the Hammer of Ragnaros. Put some cheese up for sale, that kind of stuff, and the demo code that I've given you has both of the ways that I showed you. It has the proper way with .insert and .find. And then you can have lines like this: database.find sulfurous points to second .name. That's a hell of a line right there. That's a hell of a line. Or you can break it down a little bit more like I showed you in the first half of this lecture. Or you get an iterator and then use the iterator to grab the stuff. This is how you can delete things also, by the way. You can do it that way. Or you can do it using the square bracket operator way, which to me looks a little bit better. Database age 3. The key for this, by the way, is the string, not social. We're using strings as the key. And so we're going to insert it into the database in slot aged brie. We're going to put an item called aged brie in there with a value of 10 gold pieces. And then we can print out the name and the price like that. It's a little bit easier than this, right? Here we're printing out the name and the price of Sulfurous, the Hammer of Ragnaros. It's a lot more typing, in my opinion, than that. But you guys do whichever way appeals to you. Okay. The one thing, again, is anytime you are outputting something from the database with square brackets, use .contains. .contains returns true or false. Is there an entry in the database containing Sir not appearing in this movie? And there's not, by the way. If there was, it would print out the name and the price of the knight, I guess, for sale at the auction house. That's a little... Okay. Maybe I didn't think that one through a little bit. But he's not there, so it doesn't matter. It's not slavery. We're good. And so it returns false. Sir not appearing in this movie is not there, and so it's going to print out Sir not appearing in this movie. It's not found. There is no quantity. Each item is unique. So I thought about adding quantity, but it's going to present a problem because each item also has an expiration date on it. And so if you have milk and you add milk on Tuesday and you have milk on Thursday, they have different expiration dates. So do you increase the quantity on that? Like, how do you handle different quarts of milk with different expiration dates? So what I decided was just to have every item have its own unique name. So you might have milk 1, milk 2, milk 3, no quantities. I thought about it, though. All right. So here's the directions. Write your program here. There you go. It's very helpful. I know. You're welcome. Just do it all. Do it all there. I give you, it's like demo code. This is like basically everything you need for the assignment, at least as far as like standard library calls and things like that. Demo code shows you how to insert, how to search, how to delete. Kind of got everything you want. So clear and definitive. Thank you. Yeah, exactly. There you go. There you go. You are welcome. You are welcome. Okay. One thing I do want to see from you guys is proper class design. I do not want you to see. I do not want to see using namespace standard. You're like, what? Is this Kearney? Has he been replaced by a doppelganger? No. This is actually something I've been pretty consistent on. Don't use using namespace standard in a header file. That's the rule for good class design. Like when I release header files that other people use, you will not see me have using namespace standard in it. And the reason for that is because I understand other people are stupid, right? Like I get it. Like I get that they have their like thing against using namespace standard. So I'm not going to enforce my correct and proper beliefs upon them, even though I'm right. Right? And so I'm sorry. Can't keep straight face doing that. Yeah, but in general, the rule for header file is don't use using namespace standard in there. Even doing something like this is a little bit dubious because what happens is that when people use your header file, you're making a design decision for them. You're saying you must use using namespace standard because I did. And so even though my .cc files will all have it in there because I have used C++ for more than a year and I know it's in the standard library, I don't put in my header files. I put in my .cc files, but not my header files. You can just include part of it if you want. So you can notice here I didn't have to say std string because up here we have using std string. Even that's a little bit dubious because you're making a design decision for them to use string without studs if they choose not to. But that's a lot less obnoxious to people than importing the entire standard namespace into their project. You don't like my style? Make your own headers. Fair enough. And but true, like when we get modules, which modules are coming soon. In the year 2020, we will have modules. Any day now, it'll turn into the year 2020, and modules will be here because it's part of the C++ 20 standard. So I'm looking forward to next year when it's 2020 and we finally have modules. That's going to be exciting. 2 more weeks, I know. 2 weeks ago until it's the year 2020. Oh boy, it's like Christmas. Okay. But my point is, like, once you have modules, you can actually use using namespace standard in your module, and it doesn't transfer into other people's stuff. If they import your module, which is the new way of doing like a hashtag include, if you import a module, it doesn't actually, if they use using namespace standard in their module, it does not transfer into yours. And so it's nice and modular, the modules are. So I'm excited for that too, because then I don't have to worry about this stupid bullshit anymore. Okay, so any day now it'll be 2020. Yeah, pandemic, here we come. Here we come. All right, COVID 2020. All right, any day now. So, all right. So what we have here is a basic class that is PODZ. It's a plain old data structure. You're going to need to use proper class design. You need to use getters and setters and constructors. There's only 2 elements in it. You're going to add 2 more for a total of 4. So every item has a name, an expiration date, a price, and a special attribute. And I'll go over that in a second. I only did half of it because I want you guys... I originally actually had all 4 in there, and then Mincarelli's like, no, they need to write it. They need to get the practice. So I'm like, all right. So you can thank Mincarelli for that. Here's the bus. Tossing them under it. If you want, you can delete the default constructor. That'll prevent the square bracket operator from working. That's a decision you have to make. I have a default constructor here, and I have a 2-parameter constructor here. So if you ever see Untitled Goose Game appear in your database, that means you screwed up with the square bracket, and it put an Untitled Goose Game in. You should never see Untitled Goose Game in your database. But if you do, that means that you were reading with a square bracket without checking to see if the thing was in there first, and it put it in for you. Thank you, C++. Standard, very cool. So, yeah, You Done Goofed is another good name you can put in there. You guys need to write the double left arrow and the double right arrow operators for it, getters and setters. That's about it. I just want to see you guys do this. You can have a separate, so you can either do it like this, where just everything's in a header, item.h, or you can do item.h and item.cc if you want. It's up to you. I'm agnostic on the matter. If you do a separate compilation, then you'll need to make a makefile, which would be a good experience for you also. All right, so let's take a look at main.cc again. And again, we have the complete directions here, write the program. So what you're actually going to do is this. So when you start off, the user is going to type in a file name, and the file is going to contain something like this. And it's a list of items for sale in the market. And each item is 4 lines. First line is the name of the item, which is also the key. The name is the key in this case, which means no names can be duplicates. If you try adding an iron helmet to be sold when you already have an iron helmet for sale, then that is a die. Okay. Second item, second line is the price. So 20 gold pieces, 30 gold pieces. All prices have to range from 1 to 100. If the file contains a price that's negative, die. If the price contains something that's over 100, die. With the exception of sulfurous. The third item is the expiration date, and this is what makes the assignment interesting and fun. So every item has an expiration date or a sell-by date, because iron helmets don't, expire like milk does. But what this is if the item hasn't sold after 3 years ish. If it hasn't sold after 1,000 days, then it goes on sale. Yeah, maybe it rusts, but it goes on sale. So basically, for every day past the sell-by date, and the first day of the simulation is day 1. So sulfurous has to sell by day 7, and if it doesn't, the price drops. The price goes down in price by 1 for each day that goes by. If the price ever hits 0, it's deleted. You throw it in the trash. Okay? So the iron helmet on day 1,000 is 10 gold pieces. On day 1,001, it's 9 gold pieces. Day 1,002, 8 gold pieces. And once we get to day 1010, the price hits 0, and they throw it back in the trash. Okay? Donate to Goodwill. Exactly. And then the fourth thing here is the special attribute. The special attribute can be none, in which case it's just a boring iron helmet. But there's a couple special rules you have to follow, and here's the list of them. So none is none. It can only have one. It can't have multiple of these. So if it's a conjured item, like conjured water or whatever, the price drops by 2 past the expiration date. So if you have conjured food, after the expiration date, the price drops by 2 until it hits 0. It goes away. Aging items like cheese and wine go up in value. So the older the wine is, if you have the 1937 Chateau Latour, which is one of the premium cru vineyards in France, the value actually goes up. Every day that goes by, the price goes up by 1. Okay, so they don't have an expiration date. It just goes up in price every day until it hits the maximum of 100. Okay. A legendary item, like sulfurous, can have a price over 100. And this is going to make it a little tricky for you, because when you're reading your data in, normally you vet it, right? Like you read in the price, you're like, oh, if the price is below 1 or if the price is over 100, die. You can't do that until you've read the attribute. After you've read the attribute, now you know if it's legendary or not. If it's legendary, it can have a price over 100. Still can't be negative, but it can have a price over 100. If it's not legendary, then you die. Okay? At that point. And then finally, we have limited time tickets, like tickets to a show. The price goes up by 2 every day until the expiration date, and then the value drops. So if you have tickets to see Michael Jackson as he comes back from the dead as a zombie or a werewolf or something, as it gets closer and closer to the concert date, the price goes up and up and up and up and up. And then after the concert's over, the ticket's worth nothing, and you delete it. Thriller, exactly. So, so for limited time things, the expiration date is the cutoff, and then it drops to 0 and it's deleted afterwards. After you've inserted all of the things into the database from the file, so you're going to load from a file. I hope all you guys remember how to read from a file. How many people here remember how to use IF streams and OF streams and things like that? And how many don't? Yeah. If you don't use it, you lose it, right? And so that's one of the reasons why we're doing practice of this, is to keep your skills up, and to learn how to parse and things like that. There's a little bit of tricky stuff here. You have to read just the 47 and not the GP. So that'll be a little bit tricky. Originally, I was going to have the none not exist, and it would go like that. And that would be tricky, because how do you know if you're reading an attribute or if you're reading the name of an item? Like, that's tricky. You'd actually have to look at the line after that and see if it's a number to determine if the line 2 lines before it was an attribute or not. And I was like, it's going to be too hard for him. So, also, I didn't want to write it myself. That's some AOC nonsense. Alexia Cortez. What's her name? Okay. Anyway. So what I did instead was I added the little GP here. So you have to read the number part and not the letter part. So, Advent code. Yeah. It is quite common for Advent code to add little bits of nonsense to the parsing just to make it more difficult than it needs to be. All right. Yeah. So after you have inputted everything using your file stream skills, then you are going to begin the simulation for realsies. The user will give one of 4 commands. Stock item, which is insert. You add a new item to the database that can be sold. Purchase item, delete. You delete an item. I guess I didn't say what happens if you try purchasing something that's not there. Probably die, I would say. But let's say you buy Sulfurous, the Hammer of Ragnarok. You write down, okay, that was 222 gold pieces, right? And at the end of the game, it's not really much of a game. At the end of the program, you print out the total amount of money spent by the user. Here's a check for $500. So you're going to be inserting things into the database. You are going to be deleting things from the database. You're going to be searching the database. So we're doing insert, search, and delete. The 3 basic operations we do for everything. To search the database, you do a price check, essentially, like, hey, do you guys have a sulfurous in stock? And it'll print out item not in stock if it's sold out, or it'll print the information on the item if it is in stock, like what we did in the first half of this lecture. Print out the name, the price, the special attributes, that kind of stuff. And then finally, and this is the thing that makes the simulation interesting, the day can move forward. And so as time progresses, everything that has expired loses 1 point of value off of them. How to handle that, I'll leave up to you guys. There's different ways of handling it, some of which are better than others. The worst way of doing it would probably, every time you advance the day, you iterate across the entire hash table using something like this, where you loop across the entire thing and go through everybody's, dot second dot value and decrement it by 1. You could do it. You could do it. It's not the best way, but you can do it that way. So every time the day moves forward, if the item is expired, you reduce the price by 1. And if the item is now at a price of 0, it gets deleted from the database. Okay. That's it. That's the entire assignment. So, yeah, use proper class design, use them hash tables. Your code will probably fail test cases if you try doing this using anything but a hash table. I'm still making the input files. They're not ready yet, but expect to have like maybe hundreds of thousands of items in your database, and for maybe thousands of days to go by, if you want a hint. Okay. If you use a vector, you're probably going to fail. All right. I've only graded one piece of the midterm debugging. Yeah. I was grading it when class got out, so don't worry about the midterm grading it. It's still a work in progress. Bigger hash. Yeah. What happens is I have to grade A first and then put the points in for that. Then I grade B and add the points together. Then I grade C and add the points together. So it's just kind of an iterative process, but I got interrupted in the in-person class doing that. Okay. That is basically your assignment. You guys got a week to do this, unless you want less time. Anyone want to vote for tomorrow at midnight? 1 week's good. You got physics test tomorrow. We vote for 2 weeks. Nah. 1 week is good enough to do this. You're basically just going to be inserting, searching, and deleting from a hash table. The only tricky part is going to be getting that time advancement to work, so you can decrement the price of everything in a reasonable amount of time. So that's going to be the big brain thing. You might lose a point or two if you can't think of an efficient way of doing that. You're doing Verona also, just you. Yeah, nobody else is. Yeah. All right. So this thing is inspired by this project here. If you search for Gilded Rose online, it's a fairly famous problem, but it's a refactoring problem, and so it's not exactly the same as what I'm giving you. If you copy code from it, you're not going to pass the test cases because it's different. It's kind of inspired by it. This is what happens when I hang out with my brother-in-law, by the way. My brother-in-law is a programmer who talks at conferences on refactoring and ways of programming, and testing code and stuff like that. And so whenever we get together, we were like inner tubing down a mountain together on the snow, and talking about this homework assignment for you guys. So you can thank him. Like last year's students did shapes, which I think was their hardest assignment. That was his thing as well. So we're gonna be doing another crack at that one later in the semester too. RTX on, yeah. Talking about how to not torture students, like interesting and fun homework assignments. That's what we do. Farkle, RTX on, SDF2, yeah, that kind of stuff. So it's anytime I hang out with my brother-in-law, you should worry. But in all honesty, we're gonna redo the shapes assignment for you guys this semester, and it should be fun. Should be fun for somebody. Maybe me. Maybe you. Maybe the 45 students who are going to be grading your stuff. So definitely just me. Nah. Like I told the 45 students to expect this. They're actually going to be grading your homework or something along those lines. So they're excited. They're looking forward to this. Can you write code in Russian? I don't know. We'll see. That's upcoming. Okay. So that is it for today, guys. Can you write in Chinese? It's going to be given to you in Russian, maybe. I don't know. We haven't worked out the details yet, but we're going to try and give you guys code as bad as possible. It'll be fun. So you can do a Russian accent. Does that count? I don't know. You tell me. All right. Any questions about Gilded Rose? There you go. Yeah, this is a pretty famous thing. So this assignment is inspired by it. It's not the same assignment though. No way. No. All right. That's it for today, guys. Thanks a lot. I'll see you guys on Friday.